Okay, good afternoon, good morning, whatever. Today's going to be the second tutorial regarding the use of GOCV for computer vision in the Go language. So in the first episode, we looked at a simple way of streaming the webcam feed on a web browser on my Raspberry Pi. But this could be done with a webcam on your own computer if you wanted to. But since this is going to be a series towards robotics, I thought the Raspberry Pi would be a better platform. In this episode, I'd like to go a bit further and do some simple face detection using the cascade method. So it's quite simple. It's again in the if I open the web browser, it's in the examples from the GOCV library. So if you go into writing code, you got hello, and then you got face detect. So simply this. But what I'll do is just because I don't have a screen on my Raspberry Pi, I'm just reading it through SSH. The idea is to fuse this code with what we just saw and stream basically this result to a web browser. So that's the gist of it. What we're going to do is just add a new folder here, tutorial 2. So as I said last time, I'm using Atom from GitHub, and it's a very great and customable IDE, text editor. And I'm using this little plugin, ftp-remote-edit, to FTP into my Raspberry Pi, and I'm therefore able to edit code directly in there, and it will be saved on the Raspberry Pi, and then I can use this little terminal SSH program on Windows, which is absolutely awesome, Mobo Xterm, to SSH into the Pi and basically just run the stuff. Great, so let's get started. What we're going to do is make a new folder, new tutorial. I'm going to call this main again. I'm just going to copy and paste what we saw last time. So this should be, I think I've not done it yet, but this is going to be in the GitHub repository if you want just to fetch the code over there. Great, so we can say that. I'm just going to add a README just so it's there, even though it's going to be empty, but anyway. Great, so what do we want to do? If I look back at the code, this thing basically captures the image simply with this. I don't think we're going to need this anymore. In there, this is everything that's going to use the that's going to serve the captured image from the webcam. So what we want to do is keep this, and we're going to change the coroutine function. So if I put like capture, no, face detect, for example, face detect, and this is the function we're going to write today. So for the imports and all this, we'll see that at the end. Okay, great. So first thing we want to do is import the XML file, which we'll need to upload to the Pi. So first what you do is declare where this XML file is going to be. So we just declare the relative path. So it's going to be into, let's say, assets dash. I'm just going to copy and paste the name, the one I use. You can use different, so you can find this file if you go to opencv on GitHub. Oops. Give me a second. Google's asking me to send my life. So if I put back here, opencv, if you go into, let's just search for the file in this repo, XML. And here we are. So it's in the opencv data, and you've got different files there that will detect different parts of the body of different objects. You can detect, if I zoom in a bit in, you can detect the eye, the frontal cat face. Yeah, cat face is a very popular full body. Left eye, apparently. Right eye, Russian plate. So these, we'll see maybe in a later video how to make them, make your own. It's quite long and involved, so we'll see. Actually got my model running in the background right now. Anyway, so the one we're going to use is, well, this one basically. It's going to be the frontal face out. You could use the default if you wanted to, but yeah. Okay, so now we just continue the code. Great. Now we're going to make our matrix, so GOCV new mat, and we're going to defer the image close. Then we're going to make a little blue, a blue variable, which is just the color blue, RGBA, to basically make a square around the face. So you can change the color here. And then we're going to make the classifier. So it's basically interpret this file. So it's going to be classifier, GOCV new cascade classifier. And again, we're going to defer classifier close. Got something banging somewhere, I don't know what it is. It's quite annoying. Sorry about that. Great. Now we're going to read the file, but we need to capture the error if for whatever reason the file doesn't exist, or it can't be found or can't be opened. So classifier.load, and we load the XML file. But if this doesn't work, we just panic. So ftmtp print f, pardon me, error reading cascade file, and we just put the string of what was the file we gave. Okay, and then we simply return, which will close the program. Okay, that's great. Now we just make a simple for loop, which will basically is the main loop, which will read the webcam, and afterwards it's going to look if there's any faces in it. So if okay, different. So this is similar to what we did earlier, or last time. I mean, webcam dot read, and we point our image matrix, and if it's not okay, we just show that we had an error. But as last time, in the example, he returns, so basically closes the program. In my case, I've seen I've seen that a hiccup might happen, but the program might still work. So device skipped, let's say, and we just give string or value. We just give the device ID. Device ID. Next is image. If the image is empty, we just restart the loop or just continue. So if something else happens, we don't want to run through the whole loop. We just start again, basically. Yep. And now we detect multiple faces. So there are different functions for that. The one that's in the example, and that works quite good, will detect as many faces as there are. Might show some false positive. But anyway, so it's detect multiscale, and we give it the image. And what we can do is print f value faces found. So it will tell us if it found any faces, and we'll give it the length of rect. Rect being some sort of list that will list all the faces and coordinates in them. Great. So if we take the length of rect, it's the number of faces, basically. And what we can do now is iterate through this. So if it's 0, it won't do much, of course. But if it's if there is a face, so if range rect, well, we just want to draw a square around it. So for that, we create a rectangle in which we give the image, pointer to the image. Then we give it the R value, so that would be just the values of where the coordinates or where the face is. We give it our color, and we give it the number 3, which I don't know what it does. It could be interesting to look into documentation. GOCV rectangles. Rectangle. So it's the thickness. 3 is the thickness of the. So yeah, 3 is the thickness of the line. So we could put this to a small value. So for 1, for example. Okay. Now what we want to do is put a little text, which will say that we found a human. And this will be helpful later when we want to try to find if we found the right person. I'm still working on this. I don't know if it will work on me, so we'll see. Anyway, so we put human. So this is just a string. Yeah, we can just do that. Yep. No, F. Yeah. And I don't know if I have to give it some values right now. Let's just do that. String, and we give it R. So we'll see what R is. Then we define the size, which will be the size of the text. GOCV get text size. So we give it the text. GOCV front her she plain. Don't know what that is. It was in the example. It worked. Maybe later on I'll look into what it is exactly, but yeah. Good. Then PT point will be image. So using the image library PT, which will give it some coordinates. So it's R min x plus R min x divided by 2 minus size x divided by 2 comma R min y minus 2. I don't know what this does. I guess it just finds where to put the text. So this can be very tedious to determine on your own, but yeah, it's again in the example. And then we just put the text on the image. So we give it the pointer towards the image. We give it the text. We give it the points. And then just some other stuff to make it work. She plain, then 1.2, then the color, then 2. So for each face found, it will draw this square and write human, as well with the R stuff on top of it. And now we simply do like we did last time, and stream this, encode and stream. Excuse me, I need to blow my nose again. So GOCV image encode. We want JPEG image, then we stream it, and we update JPEG and the buff. So that's our function. Now we just need to make sure we got the proper imports. So I'm going to choose and look at the list. So we need the image, we need image color, we need, I don't think, yes, this is needed. I think that's it. So let's save this, upload it to my Pi. If I open a terminal and I need to actually go to this folder, so I'll just copy the remote path. Here we are. So go run main. Let's look at the first error. So we forgot a bracket. Line 41. Okay, if for, okay, we've put one too many brackets here. This one is too much. Let's try again. Maybe it wasn't. Okay, I just need to make sure all the brackets are there. Okay, so this if is okay. The main is okay. This if is okay. This if is okay. This for loop is okay. This for loop is okay. This if is okay. And we're missing a bracket for that. Okay. And that should work then. Expected. Line 41. What did I do wrong? Oh. It's a semicolon here. Semicolon. Yeah, I don't know. Okay, so undefined front. Okay, I might have mistyped this. So where is it? Line 54. It's in there. 54. Yes, this is a mistype. So it's not front, it's font. Oh God. Cut. I guess allergies in the air. Oh yeah, so what I meant, I forgot to remove the terminal. So first thing is I put a semicolon instead of a double. I put this instead of this. Okay, that was the first mistake. Second mistake, I put an R here. It's not front, it's font. And from there, so it works, but we didn't download the file. So what we want to do is go into, yes, this is my cheat sheet. In here, I need to download the front face, so this one, so we can open this in a new window. We take the raw, and what I can do, there are different ways, but because this is just a text file with values, what you can actually do is just go in there, create a new folder which is assets, and in there we'll just copy this name, new file, give it this name, and then we just so we just copy all this. And what I was doing is basically in here I've made a new folder which is assets into tutorial, and make this file with this name, and then I just paste all this in. Okay, and then if I save this, it's uploaded into the Pi. So if I open back the terminal and start again, okay, if you see weird characters like this, it's because I got okay, so it works. I got a little program which is called caffeine that prevents my computer to go to sleep. But yeah, I'm going to close out of this and just add a new line to this found face thing, because it's going to annoy me otherwise. So it was found face and then N. Okay. Then we go back in here. We run this again. So it's going to do the other thing, and we can go into our terminal here. Oops. We can navigate to the Raspberry Pi. Wrong port. Yes, wrong port. It's 2. And here we are. So this is another point of view. So here's my face. You can see that it can grab. Well, it's very slow. Okay, it's very sluggish. But it grabs my face. Okay, so all we can do to reduce the latency is, yes, if we go there, we can see that the Pi is running at nearly 90%. So it must be getting very hot. So I'm going to stop this and just reduce the size of the window like this. So again, all this this main function can be found in the previous tutorial. So let's try that. Run this again. It's a bit faster now, and just refresh this window. So now, okay, there's some latency, but at least the FPS is okay. How to make this better? Well, there's not a lot one can do. It's just a question of yeah, you could reduce the FPS if you wanted to. This might reduce a little bit of the latency. We can try this, see what happens. So if I go back here, stop this, remove the terminal, the FPS is set value 5, and the FPS value, we can put this maybe something like I don't know, 5. It's quite sluggish, but again, Raspberry Pi is not known to go quick on these kinds of exercise. So you would need something that would accelerate the computation, such as well, the Mobius from Intel have actually ordered this, as well as the Coral from Google. And okay, so it's slower because fewer FPS. If I go back here and refresh this, okay, there's a little bit of latency, but I mean it's usable for. I was saying this is usable for to as a start. Okay, so we got the coordinates. We can actually follow the face quite well. It does not recognize me specifically if I don't know where my phone is. If you put any face in front of the camera, we'll see it. If you want to recognize a specific person from another, you need the 2 ways. One which is slower, you can use a recognizer that will train on a small amount of images, and it works, but on the Pi it is slow. Or you can make your own cascade file, which I'm actually testing at the moment. So that's it for today. If you have any questions or remarks, you can put them in the comments. I'm going to put all this on GitHub and put the links in the comments. What else in the descriptions? I mean, you know. Yeah, in the next video, what we'll do is on my setup, I'll put some motors on this webcam, and the idea, as I said, is because we know where the face is. If it's too much on the right or on the left, the webcam can actually move, and this works. I got it working. Works quite well. So this is going to be the next video. So I think that's pretty much it. If you have any questions, please subscribe, please comment, or you know how to use YouTube. Anyway, cheerio.